All right, we're going to look at some more examples here of, we're going to focus on elimination for solving equations, but I also want to remind us that we've been talking about the different types of solutions we can get, and you're going to see what I mean here, okay? Now, we're not going to verify the solution we're not graphing right now, okay? Determine the solution to the variable by determine the solution to the system by eliminating one of the variables. So it's telling us to use elimination. But I want you guys to understand, you could solve this by graphing. Using intercepts or solving for y and putting it in slope-intercept form, you could solve it by graphing. You could solve for one of the variables and you could use it by substitution. But normally when it's written in standard form like this, if possible, the best thing to do is use elimination. Look at your coefficients and see if you can easily make opposites, okay? So right now I have negative 12 and 3, not opposites. I'm going to make this plus a negative 5, and I have 20 and negative 5, not opposites. But I can maybe make this, if I made this positive 12 here, it would be opposites. So I'm going to choose to multiply everything on this bottom one by 4, okay? So my top equation is staying the same. And now this is a 4 here. I'm going to go 4 times 3x. Well, that would be a positive 12x. Since I made everything addition, I can put plus signs there. 4 times negative 5y. Well, 4 times a negative 5 is negative 20. So I get negative 20y equals, whatever we do to one side, we got to do the other. Okay, so it's kind of like the distributive property. I have to multiply everything by 4 on the left, but I also got to multiply the right side by 4. 4 times a negative 4 is negative 16. So now, add them together. That's what elimination is. That's why it's sometimes called linear combination, because we're combining them to get something to be eliminated. Negative 12x's and a positive 12x's give me 0. Positive 20y's and negative 20y's give me 0. So everything here on the left gives me 0. That's okay. We just got to see what happens on the other side. If I can draw a 0. 24 plus a negative 16 or 24 minus 16 is 8. I don't think that's true. I don't think 0 equals 8. So remember what I said is like, I also want to remind us of the different types of solutions we could get. 0 is never going to equal 8. So if it can never be true, we say there is no solution. Oh yeah, remember? We can get 1 point as a solution, we can get no solution, or we can get infinitely many solutions. So don't panic when you see this. I mean, double check to make sure you added correctly. But if you get 0 equals 8, it's not true. It's never going to be true. That means there is no solution to this. There is nothing that will make both of these sides equal these sides. Okay? There's something that makes this equal this and this equal this, but not all together. So that's kind of what we're doing right now. Okay? So let's just look at a couple more examples. All right. So looking here, we have x, I'm going to say plus a negative 4y equals 7, and 5 plus 9y equals 6. So if I wanted to make opposites here, and you can multiply both equations, okay? I could look at this negative 4 and 9 and say, well, I can make this negative 36 by multiplying by 9 and make this positive 36 by multiplying by 4. So you can multiply both equations. I'm going to try not to. If I look here, though, I have a 1x and I have a 5x. Well, if I can make that 1x a negative 5, then I'll have an opposite. So negative 5 times 1x is a negative 5x plus negative 5 times negative 4 is 20y equals, whatever we do one side, we got to do the other, right? Negative 5 times 7 is negative 35. And then I can just bring my second equation over. Again, you could multiply both by something, and eventually you'll have to. But if I did it this way, I don't have to. Okay, so now that I've dealt with opposites, I combine them. Negative 5x plus positive 5x, gone. 20y's plus 9y's is 29y's. Negative 35 plus 6 is a negative 29. Solve for y by dividing both sides by 29. And we get y equals negative 1. Okay, so in this case, we've got a value, right? We know what y is. So now we have to figure out what x is. So remember what we do is we pick one of the equations, it doesn't matter which one, and we plug this value in for it. So I'm going to take this top one here, x plus a negative 4y equals 7, and I'm going to put -1 in there for y. So this is going to be x plus -4 times -1 equals 7. X plus -4 plus, I'm sorry, -4 times -1 is +4 equals 7. I'm solving for x, so I have to get rid of the 4. It's +4, so I'm going to -4, or put it with a -4. Whatever I do to one side, I do to the other. Left with x, this is 0, equals 3. So our x value is 3, our y value is -1. Okay, so this one has a solution. Okay, you probably can guess what this last one is. And again, if I'm going too fast, pause it, copy things down. Okay, re-listen to things if need be. Let's look at this equation here. Okay, do I have some opposites? Well, -12 and -2 aren't, 30 and 5 aren't. But maybe if I just look at the x's, and again, you could look at the y's. It doesn't matter because eventually, if there's a solution, we're going to find both an x and a y value. But looking at this, I'm just going to look at the x's, right? -12, if I could make this a +12. How do I make, what do I multiply -2 by to get a +12? I'm sorry, -6, right? Negative times a negative is a positive. So I'm going to go, my first equation is staying the same. I'm going to go -6 times -2, which is a +12x. -6 times -2x is a +12x, plus -6 times -5 is going to be a -30y, which is going to equal -6 times -3. Negative times a negative is a positive, and that'll be a +18. Watch what happens here. Hopefully you're looking at this going, oh, wait a minute, there's a lot of similarities going on. -12x plus 12x, 0. 30y's plus -30y's, 0. We've seen that before, but remember I said wait and see what happens on the other side, right? Because we had no solution before. But over here, this is where it's different. -18 plus 18. Well, that's 0. Well, does 0 equal 0? Yes. Okay, this side is the exact same thing as this side. And so if you get that, there's not no solution. There's infinitely many solutions. If we were to graph them, they'd be the same line. Okay, so those are the different types of solutions we can get, even when we're using elimination. All right, if we get a true statement, this side is always going to equal this side, there's infinitely many solutions. If we can solve for a variable, we know there's one solution, so then you can figure out what the other variable is. And if we get an untrue statement, not going to happen, there's no solution.